Good morning, one and all. Today our topic is wing trains in hydraulic modification. So already in our last class we understand various different types of trains we used for the hydraulic modification, which is required for the soil improvement and enhancing the required properties for the desired properties which are required for the construction work. So now in this, our next one is the next hydraulic modification which we used, that is after sand trains, is wing trains. In these sand trains, people we are using in olden days. So whatever we observed, whatever the different installation procedure, what we observed in sand trains, so that is which we used in our olden days. Nowadays, everything which is depends upon the prefabricated. We are using prefabricated vertical drains. So it is composed of polypropylene strip with drainage channels wrapped in a geotextile filter fabric. So it depends upon the which type of geo conditions of that particular region. Based on that, these geotextile filter fabrics which are used for the composed for these drainage systems, these vertical systems. So in this drainage, you have a drain inside which has drainage channel. So the moment whenever we are going to apply the load, water comes here and then goes to the drainage channels. In this, inside, whenever we are using these kind of wing trains, using this fabric prefabricated, which based on the filter fabric, in that the channels, whenever we are considering this channel, based on the type of the movement we are going to apply, comes, and whether it is go to the based on the different types of drainage channels. So the process is different. In previously, we are going to construct such types of sand drains using these vertical drains as well as the horizontal drains based on the surge load. The combination of all these things, it may cause some kind of disadvantages which in it. So in those kind of once we observe the absorption of the soil from water and some leakages, these kind of they may affect the required properties and desired parameters which we require. It may affect. So it may lead to the effect. But coming to the wing trains, we have to based on these prefabricated gives some advantages we may overcome from the sand over the sand drains. So in these sand drains, the complete coming to these wing drains, it's completely prefabricated. These vertical drains insulated to accelerate the consolidation. So consolidation of the compressible soils. Once the soils are going to the compressible, it is help us to accelerate the consolidation procedure for improvement of the ground, whatever the desired properties. So the drain consists of a geotextile filter wrapped plastic strip with extruded channels that allow water to drain from soft soil as it consolidates under an applied surcharge load. Here also, based on the surcharge load, we are going to use the required consolidator under the pressure which is there, and how we are going to allow the water for this filter wrapped plastic which contains the drain in geotextile format. So in this geotextile filter prevents soil particles from entering the channels and clogging the drain. So whenever whenever the filter is there, it prevents the soil particles to flow. Whenever some of the particles whenever they are coming from the upside or from the downside, it depends upon the direction. So at end, all these are going to settle there, create some disturbance for the water flow. So such kind of is going to prevent initially using these kind of geotextile filter. So it prevents soil particles from entering the channels, and it is not going to close the drain. It is not going to create any kind of disturbance. In this, the time required for the consolidation to occur depends on the permeability of the soft strata and the existence of the sand layers in the strata. So the weight of the surcharge and the spacing of the wings is depends upon the permeability and the how many kind of soil layers, how they are reacting, and effective weight of that soil. These are all the parameters which we are going to deciding the spacing of the wings. It depends upon the all these parameters. First, the permeability of the soil as well as the existing sand layers in the that particular strata in that particular region where we require. So the weight of the surcharge and the spacing of the wings. So like this we are going to understand the wing drains. So coming to these wing drains are going to apply any site which is requires consolidation and includes the main motto of these is the requires consolidation and includes sites for roadway embankments, bridge approaches and overpasses, storage tanks, dams, residential buildings, railway embankments, mining ways and tailings. So these are the major applications which we applied for consolidation, and mostly whenever it requires the consolidation we are using these kind of wing drains. So the installation procedure, coming to the installation procedure of the wing drains. Before installation can begin, the working surface must be prepared to ensure a stable working platform. Like this, we are going to consider one stable platform for the wing drains. So once the working platform is ready, we are going to typically whenever we are using this kind is completely soft, or whenever the soft and a sand or gravel blanket may be needed to provide support for the equipment. So we are using these for wing drains, we are using these kind of equipment. So for this we require typical soft and or a sand or gravel blanket we are provide to support the equipment for installation of the wing drains. Wing drains procedure, whatever the workspace that is required. So in this, first the ground water the working platform is required. The supporting system of the layers is required. After that, the sand and gravel will also act as a drainage blanket to direct water away from the treatment area. And drains can be installed up to 140 feet deep from a tank mounted excavator. So using these kind of tank mounted excavators, we are going to install till 140 feet deep. So these kind of drains can be installed using the equipment, that is tank mounted excavator. Using this tank mounted excavator, we install the till up to the depth of 140 feet below the ground surface. So the installation force is typically provided by vibratory hammers, static force methods, or combination of these two depends upon the soil conditions. So whether the soil is soft, whether the soil is hard, and it's the combination, and till 50 feet the soil is in different conditions, it has different properties. After that it may have different kind of properties. It depends upon the which type of the soil is available layer by layer up to the required depth of the drain size. So once we are understanding this, we are going to use which type of method is adaptable for the particular soil. That decides, that soil condition decides the which method is adaptable for installation procedure. So the one is vibratory hammers and the next one is static force methods. So whenever we are moving soft to hard, we are using vibratory hammers to static force methods. So it depends upon the which type of the soil condition is there. And the generally PVD is installed by using a mandrel mounted on a installation mission. This mandrel is a metallic hollow tube, either rectangular or cylindrical, contains the PVD. It contains rectangular or cylindrical contains in the PVD. It depends upon the which type of the soil condition is going to decide which we are going to select the shape of the PVD cylinder, the tube, whether the metallic hollow tube either in rectangular shape or cylindrical contains the PVD. A disposal metallic shoe is connected at the end of the mandrel so that PVD can be easily inserted within the soil. So within the soil, the end connection and the disposal of this metallic shoe is connected at the end of the mandrel so that the PVD can be easily inserted within the soil. So the next one is the next step is, once after inserting the PVD, the mandrel is extracted while the PVD remains as its position within the ground. So whenever we are using this mandrel mounted on installation mission, the hollow tube depends upon the size what is required. Once the location is decided and the shape is decided, we easily inserted this PVD using this mandrel, and after that it is placed that PVD in that particular location and it comes back its position within the ground. The PVD is in fixed position. So the installation procedure, it depends upon the first one is the soil condition. Based on the soil condition, we are using the mandrel mounted mission for installation procedure, and once interested, it is removed from the position. So this is the wing drain material which we use. So the wing drain material is a 4-inch wide and 2.5 inches thick plastic band shaped conduct. So this is the example of the wing drain material for the rolls. It is in form of rolls. So it in terms of mm, 100 to 0.64 mm. It 100 mm wide and 0.64 mm thickness of the wing drain material we used, and it is composed of polypropylene strip with drainage channels wrapped in a geotextile filter fabric. Coming to this layout, coming to the spacing, so the typical spacing ranges from 2.5 to 8 feet on center. So complete layout usually consists of a triangular or square grid patterns. So the layout usually consists of triangular or square grid patterns. The spacing ranges from 2.5 to 8 feet on center. From the center point of view, where consideration is considered for this wing drains. So this PVD installation sequence, once we understand, so the position rig at drain location, the first one is we are going to understand the position rig at drain location, place anchor on drain end, penetrate mandrel to desired depth, its required depth, so the up to 140 feet, withdraw this mandrel, cut drain material above the drainage blanket. So this is the sequence order we follow for the PVD installation. So in this installation, we have different kinds of methods for these vertical drains. The first one is we have to understand different methods. Coming to the particular methods, driving vibration pull down. These are all comes under displacement method. In that, the first one is, in this, the mandrel with or without a disposal shoe is used in such cases. So mandrel having with shoe or without shoe, it depends. So in this particular method, it is not required. In driving vibration pull down, static force we are using washing combinations of the above. So for this particular method, these are the remarks which we are understanding for this displacement method. Next, drilling method. So the first one is the displacement method, driving vibration pull down, that is nothing but the static force. Washing combinations are there, that means both combinations we observe. So without or with shoe of these mandrel we are using. The next method is, the group of next method is drilling methods. In this, rotary drill with or without a casing rotary hanger, including continuous standard and halophyte hangers, shell and agar methods with or without casing hand hanger. So we are using different cases are without with or without using rotary hanger, whether it is include or not. Whenever in this also we are using that equipment is mandatory. For these particular methods, those are group comes under the drilling methods. These are the displacement method, driving vibration as well as the washing combinations, both force as well as the static force. Coming to the drilling methods, rotary drill with or without casing as well as halophyte hangers methods without using casing hand hangers. These are all drilling methods with same equipment which we use, that is mandrel. The next group is the washing methods. In this, rotary wash jet and washed open-ended case and weighted wash jet, hand on flexible hose. So these are the methods which we understand is the washing methods. In this method, in which sand is washed in via the jet pipe are not suitable for fabricated drains. So whenever fabricated drains are suitable, we are using these two drilling methods as well as the displacement method, mandrel as a equipment. Coming to the, there is not required, it is the particular soil is not suitable for the fabricated drain. We are using these kind of washing methods. In this method, the sand is washed with via the jet of the pipe. We know the jet means the combination of the set of waters which are coming out forcefully through pipe. So we are using those kind of situation is created some particular methods. In that particular case, the grouping method is nothing but the washing method. In the different kinds of washing particulars we may understand, that is rotary wash jet and open-ended. Whenever we are using these washed open-ended case, and the next we are moving to the weighted wash jet, hand on flexible holes. So based on those particular methods, we are washed out the sand via the jet pipe. In this part, whenever the particular case that is not suitable for prefabricated drains. So these, whenever those are suitable, prefabricated drains are suitable, we are using group description, we are using the displacement method and the drilling method. So like that we are understanding the wing drains. So these are the ground improvement scheme which we understand. The first one is the depth of PVD, 10 meters to 180 meters below OGL. The spacing of the PVD, it depends upon the shape. Coming to the triangular, 1 meter center to center below the stacker reclines and 1.0 meter center to center for others. Coming to the consolidation and period, for 1 meter spacing 65 days, for 1.0 meter spacing. Thickness of the sand mat is 300 mm. Horizontal drainage system, so geotechnical pipes filled by gravels PVD laid horizontally, and the machinery which is used is the hydraulic stitchers. So these are the ground improvement schemes which we understand in these wing drains based on the depth of PVD, spacing of the PVD, consolidation period, thickness of the sand mat, horizontal drainage system, which type of machinery we are using. These are all comes under this ground improvement scheme. These are all comes under in our ground improvement scheme. So like this, we have to understand the based on the depth, that too below ground level, below the ground level, and which type of the spacing into particular to triangle. In particular, the spacing of PVD in case of the triangular. Coming to the advantages of these wing drains, these prefabricated drains, vertical drains which we use, that is, there is no risk of PVDs breaking installation, like while sand drains may have discontinuous if the mandrel is withdrawn too fast. But in this case, we are using the same equipment, but coming to the PVDs, there is no kind of such breaking at the time of installation. That kind of risk is avoided in these prefabricated procedure. In this prefabricated vertical drains procedure, there is no risk breaking of the installation compared to the sand drains. They may have discontinuous if the mandrel is withdrawn too fast. In this other one also, in coming to the next point, there is no risk of shear failure of PVDs during the settlement. At the time of settlement of there is no risk in shear failure point of view. And while coming to the sand drains, already we observed in previous lecture, that is vulnerable to shear failure during the settlement. And next is PVDs have the discharge capacities typically 3 to 30 to 10 to the power of minus 6 to 90 to 10 to the power of minus 6 meter cube per second, while a 0.35 meter diameter sand drain has discharge capacity of 20. So coming to this capacity in between 30 to 60, this discharge capacity for the PVD prefabricated vertical drains, but in sand drains the discharge capacity is 10 to 10 to the power of minus 6 meter cube per second. So this variation is there for both the vertical drains in sand drains as well as the PVD drains. So we have to understand this difference between these. This is the one more advantage over the sand drain for these wing drains. The next one is whenever we installed with a properly designed mandrels, effects are very much less for PVDs than the larger diameter sand drains. So the zone of simmer is directly proportional to the diameter of the mandrel used for this installation. And one more advantage is PVDs are factory produced materials under quality control, whereas sand drains are subjected to quality variance of naturally occurring sand. It depends. So whenever these prefabricated vertical drains, those materials are qualitated because they are controlled. Coming to the sand drain, they are subjected to variance. They are naturally occur. It depends upon depends upon how they occur and which places they are there. So it is not controlled material. So the requirements, the modifications are more when compared to the PVD. So whatever the required size, required material, required strength, we may control it. We are going to design these PVDs in the sand grains that subject is missing. The quality point of view, the PVDs are we designed for the required properties. But coming to the sand grains, they are naturally occurred sands. These are the advantages which we observed in wing drains. Coming to the disadvantage, if the comparison layer is overlain by dense fills or sands, very stiff clay or other obstructions, drain installation could require pre-drilling. So it depends upon the where we are going to install these PVDs. In that particular, these kind of disturbances may are the obstructs for the installation procedure. So for that, we are going to avoid all these things before we have to do the pre-drilling, jetting, use of vibratory hammer. It may or may not be even feasible under such conditions. So in some of the conditions, they are not adoptable for the location which we are required for the enhancement the soil properties. So in these kind of disturbances, these PVD drains are highly difficult for the installation procedure. It took lots of time and for the pre-work is required. So in this, general prefabrication can be performed if appropriate location only we are going to use, and whenever it is, even though the obstructions are there, the constraints are there, even though we are going to move these, the cost is very more when compared to the sand drains. So these are the some disadvantages which we observed for the wing drains. And the next installation procedure we will see in our next class. Coming to these wing drains, these are the some of the web references which we refer for the better understanding the topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.